So as we have discussed yesterday, we thought of having one more couple of more examples of the hypothesis testing. So as per that, let us continue working with this. So the very first thing is that let me go ahead with one case study. Total score in a basketball game is the sum of the two teams. Okay. An expert commentator claims that average total score is 202.5. Okay. If an suspects it is an overstatement and the actual average is less than 202.5, and then he selects a random sample of he selects a random sample of 85 games and obtains a mean total score of 199.2. with standard deviation 19.63. We have to determine at 5% significance level whether there is a sufficient evidence in the sample to reject the null hypothesis, otherwise to reject the commentator's claim. Okay. Now we need to understand the null hypothesis. H naught mu is equal to 202.5, right? Very first thing. Number two, HA column mu less than 202.5, which is alternative at alpha is equal to 0.05, means at which significance level it is they are telling 5%. 5% means 5 divided by 100, which is 0.05. Okay. And also the sample is large. If you can observe the sample size n is equal to 85. Okay. and where you need to identify the jet statistic. Jet statistics value. Okay, jet statistic value is equal to jet is equal to x minus mu naught divided by sigma. Sigma is equal to s divided by root n, right? So jet is equal to, we know what is the mean value. This is nothing but sample mean value. This is the population mean value which was raised by an expert. So divided by, what is the sample standard deviation? 19.63 divided by root 85. Okay, can you please calculate? Let me know the value here immediately. Suresh, Ashok, Kiran, Narayana, Anusha. Any value? Okay, that is good. Yes, that's right answer. So I'm making it as an approximate minus 1.55. Okay, this is my calculated jet score. Now, once we get this value, we know that this is the main curve which would represent. Okay, and here, when the jet is representing minus 1.55, jet score will come somewhere here, minus 1.55. Okay, so we need to identify whether the resultant value is getting into this rejection area. Okay, this is a rejection area. Can you please check for the jet score minus 1.55, what is the area? What is the value of the probability? And also, how can we ensure that whether it is a two tail or one tail? Huh? The commentator, see a fan claiming is trying to claim it as it is actual average is less than 202.5. Hence, whenever they are claiming it for less than, obviously the left tail needs to be considered. We don't, yeah, it is not full tail. Okay, when do we use the full tail? Means both left hand side and the right hand side when we have not equaled. Right or wrong? Okay, it was given by Narayana. So Narayana, can I say that the probability? Can I say that the probability is somewhere around 93.94% is wrong actually. Okay, are you calculating it for 1.55 or minus 1.55? I request you to make 1 minus 90, 1 minus 0.9394. Can you please make this and let me know? Might be you might have checked it for the 1.55. For 1.55 it is 93.94%, but you need to make 1 minus or 93.9394. Yeah, so the p-value, remember this one, this is called a p-value, means probability value, which is equal to 0.0606, which is greater than at the level of 0.05, which is equal to the value of alpha. Okay, since the test is the left tailed, the probability value is just the number which is 0.06. Okay, so the 0.06 is the value which is less than 0.05. So can you please tell me that decision? We wanted to identify for the 5% significance level. So 0.05 is less than 0.06 or not? Yes. This 0.05 is coming under this rejection area. Hence, we need to reject null hypothesis. Is it? Wrong. Will this 0.05 will comes under minus point? Will this 0.05 will comes under the rejection area? Someone tell me, man. Yes or no? So what? It will never come here. Actually, it will come here somewhere. Why? Because this is the value, this is the probability value, which is 0.06, which is greater than 0.05, but it is not less than 0.05. Okay. So the decision is not to reject the null hypothesis. So the data do not provide the sufficient evidence at the 5% significance level to conclude the average total score of the NBA games is less than 2 or 2.5. Understand? All of you? I'm talking about the rejection area. See, whenever we have a probability graph, something like this, okay, we need to verify whether it is going to be in the rejection area or not. 1 second, just let me erase this part. See, what I want to say, when we have a curve something like this, okay, and this is going to be the mean. We would be having a left-tailed or the right-tailed. These are called rejection regions. These are the jet scores. Okay. When the resultant value is lying inside this rejection area, we will reject the null hypothesis. If it is lying in this area other than the rejection area, we will consider that to not to reject the null hypothesis. And also whether it is going to be a left-tailed or the right-tailed should be decided upon based upon the problem statement. Okay. Right-tailed will be taken when there is an assumption of the value greater than mean. When there is a value of less than mean, then it is left-tailed. When it is not equal, then it is something like this. All of you understand this? See, we have identified, see, for here maybe z is equal to what is the resultant value minus 1.55, right? What is the p-value here? What is the p-value? Tell me. 0.0606. Okay. At the value of significance, which is 0.05, can you please find the p-value? Go ahead and check the jet distribution and check it for the 0.05 significance. What 0.05 significance means, which is a left hand side. Please check it out and tell me the p-value immediately. 0.0606 is the p-value for minus 0.55. I'm not talking about it. I'm talking about the p-value for 0.05 significance level. I will show you. Wait. Look, take a look at this one. For 95% confidence level means you will get plus 1.96 as a value. Okay, did you understand now? We need to identify the critical values for the 95% confidence interval. Whenever they say significance of 0.05, that refers to the 95% confidence interval. There will be confidence interval calculator. We can directly calculate even here. What is the sample mean here that we have used? 199.2. What is the sample size? 85. Standard deviation 19.63. Confidence level. Whenever it was said 5% significance level, we need to 5% means remove the 5% from the 100%. Then it will become 95% and calculate. So this is the 95% call for the 95%. It is 195 or 203. But as per our current requirement, okay, you can see the t distribution value actually, but we went ahead for the z distribution. Otherwise, even the z distribution, we can consider this as a 1.96 as a value of the z score. So this 1.96, where it is coming under? Somewhere here, okay, which is in the positive end. Okay, so definitely that is not coming under the significant, that is not coming under the rejection area. Why? Because for the rejection area to be true, we should have the value of minus 1 point b, which is less than minus 1.55. Definitely it is not. The jet score, the resultant jet score is definitely going to be, a minus 1.55. Okay, which is a different, and which should not be considered as to reject the null hypothesis. Understand? Okay. You can clearly think only one thing, that here the significance of the alpha, okay, which is 0.05, or the result that what you have got, 0.06 is greater than or less than, it's a greater than 0.05, huh? You no need to go for the jet distribution also, okay. You are verifying all this is for, this is 0.05, right? And the rest of all these things is 95 percentage, means 0.95. But what is the result that you have got? You have 0.06, means which is coming under this segment. So you can obviously not required to reject. Are you clear so far? Do you want me to re-explain one more time? I don't mind about it. Anusha, Ashok, Kiran, Suresh, are you good? And also you can get different significance levels and their scores. Look, no, this is not the one. List is not there. For 5% significant level, for 10% significant level, you will have the such change jet score distribution values. See, otherwise I will show you here itself. If you go to the jet distribution table, you will get everything. Otherwise jet distribution calculator, jet table calculator here. Okay, jettable.com. Here we do have jet score calculator. So take a look at this one. It is asking all these things again. This is best. Look at 0.05 significance level. 5% significance level means 0.05. Okay, 0.05. Let me show you. By taking an average these two, right or wrong? What is the answer? Minus 1.645. Why? Because you need to take an average of these two, right or wrong? Huh? Minus 1.645 will definitely is going to be the jet score value. Okay, so this is how that you will identify the jet score value, which is minus 1.645, minus 1.6, and you want something for the 0.0545, which is an average of these two values. This is how you can calculate this. Okay, Fine, all of you. Shall we go ahead with one more example? You should calculate and let me know. Okay. Let me see. I will give you all the values. Okay. Let me tell you, a class teacher is teaching algebra for many years. Over the many years, the students in the algebra classes are consistently scoring an average of 67 at the end of the course. Okay. Students are scoring an average of 67 marks at the end of the course. But this year, they used a new textbook. Okay, they used the new textbook so that they will get the higher average score. Okay, so they have taken a sample of 64 students. Okay, who had a mean score of average score of 69.4, and the sample standard deviation is 6.1. Okay, so we need to determine whether this data is sufficient evidence at 1% level of significance to conclude 1% level of significance, which is 0.01, to conclude that the average EOC score is higher than the new textbook. So I will give you initial clue. H naught is equal to mu is equal to 67. This is what the students are getting, where they are expecting higher when they are using a new textbook. HA colon mu is equal to, it is not equal to, what is it? It is greater than 67 at the significance level of 0.01. Okay, for the significance level 0.01. Okay, what is the value, guys? For the significance of Z score for significance of 0.01. Okay, it is a two-tailed or the right-tailed? It is the right-tailed. If it is the right-tailed, the significant Z critical value is 2.33. Are we good? No, 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 no. Otherwise, we can see here. We have critical values listed here or not? Let me see. No, it is not there here. Here we do have, I think. See, we have a requirement of 0.01. Okay, earlier we have got 0.05. Okay, which is Z score is 1.95. No, we should also even calculate the one tailed or two tailed again. Yeah, this is the one. This is one tailed and the 0.05. Okay, and 1.64 is the right value. This one we can agree. Okay, and now at this point of time it is a one tail, right? Hmm? It is a right tailed value. So we need to verify for the right tail from Z to infinity. So for the Z to infinity, 0.01 value refers to the 2.326. Okay, so 2.326 is the value which we need to make as a critical value here. Okay, so what I can say, I'm going to draw this one. Something like this. Okay, and something like this. If it is going to be mean, and this is the 2.33. Okay, 2.33, something like this, around approximately. So if the resultant Z score, now we need to calculate Z is equal to x bar minus mu naught divided by S divided by root n. X bar is equal to mean, sample mean. What is the mean? 69.4 minus mu naught 67 divided by standard deviation 6.1, 64 students. What is the value here? What is the Z score? Tell me immediately. Okay, Narayana, right answer, it is 3.14. Okay, approximately you should get around 3.15. That is fine. So is this 3.414 is coming under the rejection region or not? Hmm? 3.14 value is coming under the rejection area or not? This is the Z score for what? 0.01 significance level. Okay, and 3.14 is coming around somewhere here. So you need to reject the null hypothesis. Are you all good? Hmm? For example, if I'm going to take 5% significance level, what would be the answer then? 5% significance level means I need to change the value, which is 5% means 0.05, which is 1.64. Okay, 1.64 comes around somewhere here again in the background, right? So still it is, you need to reject. Yeah, as per the data that we have got, we have a sufficient evidence at 1% level of the significance to conclude that the examination score of the students taking the algebra using a new book is higher than the average score of those taking from the old book. No, we have to reject the null hypothesis, right? We are rejecting this one, and we are rejecting null hypothesis, and we are accepting the alternate hypothesis. As per the alternate hypothesis, the students will get greater than 67 marks. Narayana, are you with me? Huh? See, based upon our calculation, what is the final answer? We have to reject the null hypothesis, right or wrong? Right or wrong? See, we have to reject the null hypothesis, that is fine. What do you mean by null hypothesis? The claim made by the professor, which is an average score that they are getting, which is 67. Alternatively, they have got a new textbook, and where, as per that, they are thinking that they will get greater than 67. So when we are rejecting the null hypothesis, okay, you have to accept the alternate hypothesis, right? No, I'm not talking about less than. When you are rejecting the null hypothesis, obviously you are selecting the alternate hypothesis which is greater than, where you will get the greater than 67. For the with the new book, they are going to get the more score, higher score. Are you good? Narayan, I didn't understand why you kept less than. It is greater than. If you still have the confusion, please let me know. I will clear you one more time where you are having the confusion here. No, 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 no. Why you are going for less than? See, what the professor is saying as per the claim. See, who is claiming? The administration is claiming to go ahead with the new textbook to get the more score. Okay, by picking up the sample students of 64. Okay, we never prove which is less. Why do you prove that less than 67? I don't understand, Narayana. We have only two cases here. One is null hypothesis, which is already presently running. Since from the past many years, students are getting an average score of 67. Okay, now they thought of implementing a new book, and they have selected 64 students, and they are thinking about they are going to get an average of 69.4 marks, which is greater than, which is a higher score than earlier one. So you need to try to understand whether you need to reject the null hypothesis or accept the null hypothesis. When you are accepting the null hypothesis, then you will reject saying that they don't get the higher marks like 69.4 with the new book which they are going to implement. If at all, if you are going to reject the null hypothesis, you have to accept them that they are going to get the higher marks with the new textbook. Yeah, only consider null hypothesis. Okay, why are you picking the less than? I don't understand. Even in the problem statement, we have only greater than. That's why we have been right tailed. If it is less than, it is going to be a left tailed. Oh, okay. No, 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 no. It's not like that. Yeah, even if you consider 69.4, that is greater than 67, right? Right or wrong? Yeah, maybe you might have made it as ulta. 69.4 is, and 67 is less than 69.4, something like this, right? Huh. Okay, now you understand. You have cleared your confusion, right? Okay, good. Okay, good, good. Now, tomorrow we will discuss about the ANOVA, and we will close the statistical part tomorrow, mostly. Hmm? And this is what for today. We'll meet again tomorrow. Hmm? Okay, guys, all of you. See you. Bye.